Graphene, the best thermal interface material. Graphene is considered as the best thermal interface material. Due to increasing power densities in electronic field, it has become a tough task to overcome and manage the resulting heat while designing computer and semiconductors. Obviously, the scientists feel that heat dissipation has proved to be a basic issue of electronic transport at the nanoscale. Elimination of heat is not only vital for electronics but also for energy generation, for example in the case of solar cells. Thermal interface materials are significant ingredients of thermal management. TIMs are applied in between the heat source like computer chips and heat sinks, and their function is to fill the gaps and grooves created by imperfect surface finish of mating surfaces. Conventional TIM, filled with thermally conductive particles, require high volume fractions of filler particles, FN 50%, to obtain the thermal conductivity of the composite in the range of approximately 15 W/mK at room temperature. Usually a computer chip is attached for the integrated heat spreader with the help of the first TIM layer. The IHS is attached to the heat sink with the support of the second TIM layer. The interface between die and is filled with TIM for better heat transfer. The increase in thermal conductivity of commercial TIMs from the present 5 W/mK to 24 W/mK will boost the performance in electronics but also for energy generation like solar cells. Many scientists are taking efforts with various fillers that go the base material to create composites with high thermal conductivity. For using them as TIMs, these composites have to meet a number of other requirements like paper viscosity and low cost. Ballandin's Nano Device Lab research group has achieved a record enhancement of the thermal conductivity of TIMs by addition of an optimized mixture of graphene and multilayer graphene. The thermal conductivity of the epoxy matrix material was increased by impressive factor of 0.23 at the 10 volume and of graphene loading. The epoxy graphene composite preserved the entire phenomenon needed for industrial TIM application like electronics packings. The vital point for practical application is that the scientists and researchers prepare their graphene, few-layer graphene solutions using an inexpensive liquid phase exfoliation technique. This is considered as a high-yield technique, which can be scaled up for industrial production of TIMs. It has been found out by Professor Alexander Ballandin, a professor of electrical engineering at the YC Riverside-Bournes College of Engineering, and his team members, that the presence of certain fraction of the single and bilayer graphene simultaneously with the thicker graphite multilayers was vital for the improvement of thermal conductivity. It is also said that the good performance of graphene compared to carbon nanotubes is related to the smaller Kapitsa resistance, christened after the popular Russian scientist P.L. Kapitsa, a Nobel Prize winner for physics. Between graphene and the matrix material, graphene just couples to the matrix butter, says Ballandin. It is confirmed that graphene and few-layer graphene flakes will be for better filler when compared to conventionally used alumina nanoparticles. These graphene and few-layer graphene used by the team of scientists were produced by a scalable technique with the usage of few important chemicals. The newly found graphene-based fillers are more valuable than the carbon nanotubes or graphitic nanoplatelets, which are thicker graphite particles with nanoscale dimensions. Previously some steps were taken to use highly thermally conductive nanomaterials like carbon nanotubes as fillers in TIMs did not help for practical application as they had weak thermal coupling of the carbon nanotubes to the matrix and high cost. Application of graphene and related materials. The defense men prefer graphene for coating the surface of aircraft, as it has good electrical conductivity characteristics to evade electrical damages due to lightning. Graphene is a two-dimensional carbon allotrope and the most versatile material on the Earth. It has a special phenomenon of being the lightest material at the same time strongest and can conduct heat and electricity in a unique manner. Hence its applications are large and interesting. Graphene is utilized to assist the characteristics and performance of current materials and substances. The leading scientists feel that in later stage it can also be developed in conjunction with other two-dimensional crystals to create many more amazing compounds and give room to multifarious applications. Graphene will be merely L-atom thick and is considered as the thinnest material capable of creating other materials by interjecting graphene layers with other compounds to create atomic scaffolding by graphene. This new material will possess unimaginable properties useful for many purposes. Scientists showed immense interest in two-dimensional crystals like boron nitride, tantalum, 4, sulfide and niobium diselenide, which can be utilized in combination with many other 2D crystals for innumerable valuable applications. Magnesium dioxide can be made as a superconductor by interspersing its alternating boron and magnesium atomic layers with layers of graphene. If molybdenite is combined with graphene layers will create flash memory, which will be still smaller and at the same time more flexible than current technology. Actually, to produce graphene, we have to dissect a piece of graphite layer by layer with one single unit left out to be known as graphene. This process is termed as exfoliation. Scientists say that high-quality graphene is a very good conductor and has no band gap, that is, it cannot be switched off. Hence, for using graphene in the creation process of future nanoelectric devices, a band gap has to be engineered into it. This will in turn lower the electron mobility of graphene to that of levels currently witnessed in strained silicon films. Graphene and nano experts opine that R&D has to be carried out in future for graphene to replace silicon in electrical system. Usage of graphene is vastly seen in composite materials, nanotechnology, bioengineering and energy technology. Biotechnology. Graphene plays a vital role in bioengineering in future, say the leading biochemists. There are obstacles to be studied in depth to manage intellectually. It will take more than 15 years to witness graphene in many biotechnology applications. It is essential that graphene must pass over innumerable safety, clinical and regulatory trials in a tedious way. As graphene has advantages like possession of large surface area, extremely thin in nature, good electrical conductivity and enormous strength, it is best suited for bioelectric sensory devices. For applications like testing glucose levels, cholesterol, DNA and hemoglobin level, graphene will be most suitable. The experts proudly say that graphene can be used for anti-cancer remedy and antibiotic treatment. The tissue generation is also possible with graphene, say the bioengineering research scholars. Optoelectronics is another special arena where graphene plays a vital role in liquid crystal displays, touch screens, organic light-emitting diodes etc. Defense sector welcome heartily all applications of graphene for their soldiers in battlefield. For using a material for optoelectronic instruments, it should have the capability to transmit more than 90% of light with good electrical conductive characteristics of 1 by 106 W1 ml with low electrical resistance. Graphene has the capability to transmit 97.7% of light and also a transparent material. It is a good conductor and well suited for optoelectronic devices, especially in warfront. The manufacturers of laptops, smartphones, tablets, television sets, and computers etc. fully welcome and utilize their graphene technology. Portable computers make use of graphene-based e-paper. Ultrafiltration. Graphene has the special property to permit water to pass through it and hence used as ultrafiltration medium and perform as a barrier between two substances. Recently, indium tin oxide is a popular material developed for optoelectronic devices. The researchers have clearly revealed that graphene has the properties of ito and can even be a better choice than ito. Optical absorption of graphene can be altered by altering the Fermi level, says an expert. Graphene's special properties like very high tensile strength and flexibility have made it to be applied for many opto applications. Monolayer having pores up to 5 nanometers are used as monolayer graphene filters. This causes reduction in pressure while ultrafiltration is carried out. Graphene is stronger and less brittle than aluminium oxide and hence can be used for water filtration systems, desalination unit and also for preparation of biofuel. Graphene when integrated into like epoxy is found to be the best replacement for steel for aircrafts to reduce weight and also enhance fuel efficiency. Though aerospace designers were using carbon fiber for its lightweight and strong nature, now go for graphene, which is much better in quality with low weight at the same time stiff. The defense men prefer graphene for coating the surface of aircraft as it has good electrical conductivity characteristics to evade electrical damages due to lightning. If the wings of aircraft experiences strain and stress, then the graphene aids to measure it to warn the pilot. This same quality has enabled for defense applications like armor vehicles and soldiers. Graphene has low levels of light absorption and high electron mobility and hence it replaces silicon in photovoltaic cells. As graphene costs less to produce compared to silicon cell, it is considered to be advantageous for the production of photovoltaic cells. It is seen that when silicon turns light into electricity it generates photon for every electron produced and much potential energy is lost as heat. But graphene impressively generates multiple electronics as it absorbs photon. Graphene has another advantage of having capabilities to work on all wavelengths compared to silicon, which can produce electricity only from particular wavelength bands of light. So graphene proves to be far better and efficient than silicon. There is always an issue regarding storage of energy in batteries and capacitors when not in use. It is observed that present storage solutions and methods are slow. Battery by nature can hold abundant energy but it consumes more time to charge. A capacitor has the capabilities to charge quickly but cannot hold much charge compared to batteries. So we need a component, which can store battery or capacitor without any drawbacks. At this juncture graphene comes into picture and play a leading role. It is found through R&D activities that by having graphene as anode we can charge lithium-ion batteries to render higher storage capacities with longevity and charge rate. Supercapacitors use graphene for charging effectively and quickly and also store large quantity of electricity. These micro supercapacitors find a useful place in smartphones and laptops. Electrically powered vehicles, which are to be best to avoid environmental issues and pollution, use lithium-ion batteries with graphene. Tablet PCs using graphene are now seen in every house, as it is less in weight and small in size. Newly created compounds by addition of graphene layer are superlative materials like graphene but with potentially used for even more applications.